All right, ladies and gentlemen, we're going to do a retrosynthetic analysis that makes an alkene. And we're going to start that over here. In our example here, the alkene target is cis. And we only know one way to make cis or trans alkenes using our synthetic tools, and that's from internal alkynes. So our retro arrow, which means I know how to make the molecule above the arrow from the molecule below the arrow. That's what that arrow means. And it's from this, 2 CH2s and then the cyclopropyl. Make sure, for sure, you have the same number of carbons in this molecule as you did in the target. So it goes to 5, and then you get the cyclopropyl. Good. That's my number one mistake I see on student exams. They change the number of carbons here miraculously. And I can't give them a point for this new target. So, like I just said, this is your new target. You need to make it from simpler pieces. You do know methods of making either this bond here or this bond here. Either one is okay. I'm going to show you how to make this bond here. It comes from a C-triple-C minus, because that's the only C minus you know how to make, and a carbon with a chlorine on it. There's a good reason why we're doing chlorine, because my useful reaction that I gave you has chlorine right here. So we have two new targets. This target is the conjugate base of the thing it was before it was this base of this acid, and a terminal alkyne acid. This one was an alcohol. We know how to make these alkyl chlorides from alcohols. All right. So we have two new targets again. This is a terminal alkyne. It's not acetylene though. You can't say you're done. You can say you're done if you've got back to acetylene. I'll put a little yellow circle on that. And when we get back to acetylene, we're done. And when we get back to alcohols of 5 carbons or less, we're done. This comes from another synthetic molecule where you had a C-triple-C in this direction and a methyl with a Br. CH3 with a Br. Because we know that if this meets the carbon with the bromine, it kicks it off and makes a bond.
Does it matter the direction?
No, I don't care which order you list them in. As long as I see a C-triple-C minus and a methyl with a bromine. Bromine, wait, we're not, that was this morning we did bromine. We should be doing chlorine today, or else we have to memorize a reaction that we're not given on the test. So if I do another BR, just chime in, say, Dr. Whitaker, we're on chlorine right now.
So you always use the methyl?
Use the one I'm giving you.
Okay, yeah, that's what I was going to
say. Yeah. And these are both one away from being circled. This is one away from acetylene. That gets a yellow circle. This is one away from methanol, an alcohol with 1 carbon. CH3. That gets a circle. And then we got to work on the other 5 carbons over here next. Good. It's almost done too. Oh, wait, that is done. What am I saying?
Yes.
That's an alcohol with 5 carbons. Heavens. This got done faster than I thought it was. There we go. We circled all the carbons that are in our target. So now we got to go forwards. You start with your circles. Put a nice line down here. Gray line. And part B. This was part A, the retrosynthetic analysis. And part B is the synthesis. I don't need my useful reaction. Oh, I do need my useful reaction. Leave it there. I can't see everything on the screen though. There. So we start with methanol. And I need to convert it into methyl with a CH3, sorry, with a Cl. Methyl with a Cl. CH3 attached to Cl is what I wanted to say. Don't look very far for how to do that. It's right above it. Copy out the useful reaction chemicals. We got this. There we go. Not the best pyridine drawing, but not too bad. I don't like it. I don't know why. I'll tell you why. I like drawing benzenes like this. So, excuse me if I rotated the thing a little bit. Okay, so you made that. You're here now. It needs to react with this, but you haven't made this yet. You got to make chloromethane react with acetylide. It is now time to make acetylide. Our favorite base, taking H's off of alkynes. What is it? Hydride. You can write just H minus if you want. There you go, H minus. And to get this target here, you just got to mix these two together. Show me that. Mix this with the one below it. Move the teacher's picture out of the way. And you got Cl. I don't get a Cl there. What am I doing? There are my Cls and methyls. Ladies and gentlemen, the C minus attacks the carbon. Cl minus gets booted off. You get a CH3 there. Cl minus is a side product. I don't even need to see it. So do we agree we are now here? We got this guy. And it needs to lose a proton to get to be this guy. Same base. Same base. Now you got C-triple-C with a methyl and a minus. So we got that. That needs to react with this, but we don't have this yet. We've only got this in the storeroom, alcohols. So take that alcohol. Yep, we're going to react that with SOCl2 and pyridine. So you don't need to know it's called pyridine. That benzene thing. I think the better way to draw it's like this, put the double bonds on at the end. There you go. You think I'd know that after 35 years. Okay, there you go. And you got the Cl. We're getting close. We're getting close. Got 2 more steps. Mix the two. I got to mix this with this to make this, which means mix this with this to make that. And we're going to show that purple was good for us last time. Yeah. Mix those two to get this. Move that over just a bit. There you go. And then I'll do like the student did this morning. I liked what they did this morning. They just said, next step's going to make the target. So they drew an arrow right up to the target, like that. But you do have to tell me the chemicals. Oh, she's going to go with the hydrogen and Lindlar's catalyst. Risky. The only reason it's risky, you got to spell Lindlar right. And it's not a very common name. I will accept the short form cat. You know I like cat. But there's no short form for Lindlar. It's already a short form. Oh, it's got 3 things in it. Yes, I will, because then you get partial credit if you try the things instead. Lindlar's cat, this is an aside because we're really finished. Lindlar's cat. Is a combination of palladium embedded on calcium carbonate with a catalytic poison called lead 2 sulfate present as well. There you go. And I just want to remind you, there's another way to do that. Last reaction, it's less risky. Or use for star, you can use CH3, CO2H, and comma BH3. There you go. You don't like that one? No. Okay, you don't have to use that one. All right. So that's that. And let's look at the whole deal together. And that would be the end of that retrosynthetic analysis. I believe there's 7 reactions here. 1 and 2, and then combining those is a 3rd reaction, and then 4th, and then combining these is 5th, and that was a 6th to make that thing you combined, and 7th. So this is a 14-point question.
What about the ones on the left?
Well, 7 times 2.
No, the ones on the left.
You got 7 points for the B and 7 points for the same number of reactions in A.
I thought those were 2 points and then the ones on the left.
No, 1 point for forward thinking and 1 point for backward thinking.
Okay.
And that's retrosynthesis. So there's lots of videos, just doesn't have to be videos this semester. There's videos with retrosynthesis in their titles previous semesters. I would look at them. And there we go. We got that. And